Hello and welcome. My name is Dr. Soumya Chaturvedi and this is the fifth video lecture in the series of video lectures of computer programming for problem solving in C, and this is the video in Unit 3 Arrays and Functions. Let's have some recapitulations that what we have covered in our last lecture. We have covered searching algorithms, then what is the need of searching algorithm, then we have covered types of searching algorithms, and we have also done searching in one-dimensional array and searching in two-dimensional array with the help of example set. While studying the types of searching algorithm, we have discovered a variety of searching algorithm in which the array or the list is required to be sorted. So now in this today's video lecture series, we will be covering the sorting techniques. So the objective of today's class is, first we will cover sorting algorithms, what actually happens in sorting. Then we will have a few types of sorting algorithms with the example set named as insertion sort, selection sort, bubble sort, merge sort, quick sort. Now there are some more variety of sorting techniques available, but these five are more prevalent and famous and mostly used in case of sorting. Let us go ahead. Sorting algorithms. Sorting is any process of arranging items systematically and has two common and distinct meanings. So when we say about sorting something, the sorting process have two distinct meanings. I have intentionally kept the two common distinct meaning as bold. First is ordering and second is categorizing. Ordering means arranging items in a sequence by some criterion, whereas categorization is in which the grouping of items with similar properties is done. For example, ordering is when we say arrange something in alphabetic order or reverse alphabetic order or by the sequence number, whereas categorizing is something like group people wearing black colored dresses, group people wearing yellow colored dresses. So this is categorizing or grouping with the similar properties. Now a sorting algorithm is used to rearrange a given array or a list elements according to a comparison operator on the elements. That means whenever we need to arrange the things, or in a case of ordering, then the elements of the array and the list elements will be compared with the comparison operator. So either we will be using less than or greater than conditions to swap the positions or to arrange to make a sorted list or array. The comparison operator is used to decide the new order of the element in the respective data structure. As you can see in the example set, we have initial data on the left hand side. This is the portion where we have certain data B, D, A and C. Now when we talk about ordering this data, and we have a prior knowledge of that, if we consider the alphabetic order, so the respective elements, if we want to compare, the precedence of A is greater than B. So first A will occur, then B, then C and then T. This is a very a small realistic example of sorting the things, but in case of data structures, when we are sorting, we generally use to sort data elements like the age of people, the roll number of students, if we want to make any arrangement. Let us see some more detailed examples of variety of sorting algorithms. The first one is insertion sort. Insertion sort is simple sorting algorithm that works similar to the way you sort your playing cards in hand. So generally, the array is virtually split into a sorted and an unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. I hope if you have played playing cards, you must be understanding what I am trying to say. That how we sort the playing cards, we pluck it from one place and then we put it at the suitable location to make it sorted. So if I want to say the algorithm to sort an array of size n in ascending order. Now remember, in sorting we have the criteria, either we can sort in ascending order or descending order. Now you have to remember the conditions in the algorithm, that whether you are arranging or ordering in ascending order or the descending order. Now the step 1 is iterate from array 1 to array n over the array. That means starting from the first element to the nth element. Now when I say first element, you also see the index value. We have earlier discussed that if I want to talk about the first element of array, the index value starts with 0. But here we are writing the index value as 1. Why we are doing that? Because we need to compare with the current element to its predecessor. So the idea is that we will be covering from 1 to nth array to iterate, and the first element, which is array 0 index, that will be compared as a key. If the key element is smaller than its predecessor, compare it to the elements before and move the greater elements one position up to make space for the swapped element. I hope if I'll discuss this with some numerical example, that will be more clear. So let us see the example part. This is the pictorial representation of insertion sort. As you can see, this is our, in the first line, this is our, here I'm talking about, this is our unsorted array. As I said that we will be starting from array position 1 to array position n, right? This is from 1 to n, and I have set for the last element. This A0 is compared. Now the first element, the element from the array where we are iterating, we will be seeing that this element contains data value 3. Now we will be comparing this 3 with 4. So we can see that in case of ascending order, 3 should come before 4. So what we will be doing, we will be replacing it. Now, as you can see, if I wish to insert 3 over here, we do not have any space. So what is required? We require a shift of this element here so that 3 can be placed over here. In second phase, what will happen? We will be starting with, because here we have started with array 1, we will be starting with 2 to array n, or last element, right? Then we will be looking with the value of 2. It will be compared with the previous value, and then it will be compared here also. It is lesser than this, lesser than this. So we will be looking for the actual position where this element should be inserted, right? So we'll insert over here. Likewise, in next phase, array index value 3 to we'll be scanning. And the next element 10, when we look at the value 10 here, 10 is not needed to be replaced because all the previous elements like 2, 3 and 4 are lesser with the comparison operator with 10. So we will be keeping 10 over here only. Then we will be looking in next pass with the 12. Again, all the elements before 12 are sorted, so we need not to make any change. Then further we discovered this element. Now it is required to insert 1 at its correct position. So the correct position of insertion of 1 is at the first location. So all the elements, they will be moved or they will be slided one place, and we will be having a shifting. In next phase we'll have another element 5, and then 5 will be inserted at the suitable place after 4 and before 10. Likewise, the element this 6, that will be inserted after 5 and before 10. And in the last phase, as you can see, this is our sorted array. So in this, here we have unsorted, and here we have sorted. Because you have human brain, you probably know the mathematical order of or sequence of like 1 from 1 to in the increasing order. You should remember that in all sorting algorithm, the output will always be sorted array or sorted list, and we start with the input of unsorted one. The only difference here is that how this sorting will take place. So different methods are going to decide that which sorting algorithm it is. But ultimately the output will be a sorted array. That's all in insertion sort. Let us move ahead to another sorting algorithm. This is the same example for the insertion, because in earlier we have done the pictorial representation, whereas this is the numerical representation for you, that you can see in the slides as well, that we will be starting with the index value 1 to the last element of array, and we compare it with the key which is at index 0, and likewise we identify that what will be the correct position for any element to be inserted, and once we find the position, we insert it. Now the insertion in array is a process in which if you wish to insert at a particular place, all other elements are needed to be shifted. Okay, so let's move ahead to selection sort. Selection sort algorithm sorts an array by repeatedly finding the minimum element considering ascending order. Now when I say minimum element, that means we will be doing the ascending order. If we would have covered the descending order, then we will find out the maximum element from unsorted part and putting it at the beginning. The algorithm maintains 2 sub-arrays in the given array. Okay, so we will be having 2 arrays, one sub-array which is already sorted and the second sub-array remaining unsorted. So initially we can generally say that our sorted sub-array will be blank, and we have all the portion of unsorted array in one sub-array. Once we will find the minimum element in the unsorted array, we will be placing that in the sub-array which is sorted as a first element. In every iteration of selection sort, the minimum element considering ascending order from unsorted sub-array is picked and moved to the sorted sub-array. I hope this theoretical thing will be more clear if we'll see some example. Let us see the example here. In this example, if we can see, this is the unsorted array. Okay, and in this unsorted array, first we will be finding the minimum element. Okay, so as you can see manually, the minimum element is this 11 here. Now what is required? Make two subarrays in which keep this 11 at the beginning position. Okay, once we have kept it at the beginning position, now our array is from this. First we have covered from 0 to 4, the full length, and then we find it out the minimum value. Once this minimum value, one value is detached and kept at the beginning, now we have two arrays. This is the subarray which is sorted, and this is the portion which is unsorted. Now again we will be doing the iteration part with the unsorted array. Because 11 was the minimum out of all, so it will acquire the first position in the sorted array. Then we will be finding the other minimum out of the rest. So if you want to see this unsorted array, this 12 element is the minimum. So we'll be in the next phase, we will be keeping the 12 in the sorted part. I am writing S for sorted, and these three will be in the unsorted part. Okay, then again we will try to find out that what is the minimum. So you can see 22 is minimum here, so we will now have the sorted subarray, this, and these two elements in unsorted array. But eventually this, as you can see manually, this is also sorted as of now, but you have to choose the element which is 25 here, and then we'll be placing that in sorted, and finally we have this sorted array elements. Now the good thing about selection sort is it never makes more than big O of n swaps. That means the number of elements, how many number of elements you have, only that much swapping will take place in case of burst. And it can be useful when a memory write is a costly operation, when we do not have extra memory. So the swapping is only restricted to the size of the array, how many elements are present. Let us move ahead to another sorting technique. This is a bubble sort, and let's have first the definition part, and then we will be focusing on animation. It is a comparison based algorithm in which each pair of adjacent element is compared and elements are swapped if they are not in order. So basically we will be choosing a pair of elements, and between the pair of elements we will be having a swapping according to the any condition or comparison. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. Now you have to understand that because we are just swapping the adjacent pair elements, then in each of the pass we will be shifting certain elements, and then again in the next pass we need to again make certain shiftings. Now as you can see in the animation part, the swapping is done, right? The swapping order is the two adjacent values are swapped if they are not in order. Like 3 and 1 will be swapped over here. Again 3 and 5 will be selected, they are already in sorted place. 5 and 6 are again sorted place. Then 6 and 2, then 2 will be swapped at the position of 6, as you can see in the animation. Then we have 6 and 4, so 4 will be swapped by 6. Now 6, 7, 8 are in the correct position. Then 1 and 3, 3 and 5 again. Now 5 and 2 we have found. Now 2 will be swapped from the position of 5. Okay. Then 5 and 4, again 4 will be swapped. So you can find it out that in this case, in the case of bubble sort, we are having the elements sorted from the backward direction, the maximum, and then less than that, then so 8, 7, 6, 5, this is the sequence we are getting the after repeatedly swapping, we are getting the sort, right? Now finally we have all the elements sorted. That is the sequence, right? So let us, this is the initial one from where we have started. So you can take a pause in between, and you can even try by yourself manually in with the pen and paper, that while swapping, in how many steps you actually achieve the sorted array. Let us move ahead to the next. This is again the example in which the passes of swapping are described. That in first pass, when we have swapping between all the elements adjacent one, then once we have find out the last element of the sorted array, then we will be again starting and doing so. So it is advisable that in the time of watching the video, you just take a pause over here and try to read what is written here in this example and try to make it manually, right? So that you would better understand that in a whole pass what is happening. Okay, now always remember the array is sorted, but the algorithm does not know. In case of the passes, the algorithm needs a one whole pass without any swap to completely look for that, okay, everything is sorted out. This you will understand when you try to do it by yourself. Let us move ahead to the next sorting technique, which is merge sort. So merge sort is a divide and conquer algorithm. I hope everyone must have heard this, right? For Britishers, we have always used in historical discussions that they follow divide and conquer technique. That means they split up your man and then they decompose it, or they make us weak by dividing. So here this algorithm is also utilizing this divide and conquer technique. So it divides the input array in two halves, calls itself for the two halves, and then merges the two sorted halves. So we are going to split each array in two halves, and then we sorted out the halves, and then we again start merging. There will be one merge function which is used to merge two halves. Okay, now the merge is a key process that assumes the array. Now the assumption here is that if we have one array which is starting from L and its size is till array R. Now what we are thinking, that there will be two portions or halves of the array, like array from L to M elements, and then we have array M plus 1 to R. They will be sorted out. This is sorted and this is sorted. So if we merge these two sorted, we'll have the end result as a sorted array. Let us see this with one example set so that it will be very clear. Now here I have already written the number of the order in which the steps are processed. So let us start with this. So we, as you can see, that there are 7 elements in this example, and as you can see, this is unsorted. I am writing in short. Now it is going to divide in two halves. Now you can see, because this is considering having 7 elements, we cannot equally divide. So we have one portion of array in which we have 4 elements and another portion of array in which we have 3 elements. So this subdivision of array, division of or divide of array, that will be taking process in the entire subdivisions. So in the first step we have made two halves. Now in the left half we again have, in the step 2 we again have the two sub-arrays. Now here eventually we have 4 elements, so the division is among 2. So this half, 38 and 27 is here, and then 43 and 3 is here. Then again these two elements will be subdivided. So in case of divide and conquer, the rule is we divide until we get the unity or a single data set, right? So we have only single element here, which is 38. Okay. Now with this step, when we reach to 38 and 27, this is the portion where we have started the merger, right? In this case, because in comparison to 38 and 27, 27 is less, so we shift the order, and now this sorted array has become this 27 and 38. Then we had the another half. I have written the step number also, 43 and 3. It is again subdivided, and then when we start merging it, we will be sorting it. So 3 and 43 in the 10th step. Now in case of 11th, now before that we need to merge these 4, that means 2 sub-arrays. So again we need to again sort these sub-arrays. So this 3, 27, 38 and 43, that will be the order. So we will be keeping that in a sorted form, and then we'll keep this for merger with the whole array. Now we have to move to the second half of the array, which we have left over here, and this will be, again we have 3 elements, so 2 and 1 will be composite here. So these 2 is there, and this, because this is unity, this is single, we need not to compare anything. Here 9 and 82, it is sorted itself, 9 and 82, but again the division and sorting will take place. The division and divide and conquer, divide and merge will take place. Then we have 10, so the sorted portion will be 9, 10 and 82. Now in the last we have the first element, which is lesser than this, so first element will be 3 only. Then we will be comparing 27 and 9, again 9 is less, keep 9 over here. Then we have 27 and 10, then 10 is less, keep 10 is here. Then we have 27 and 82, 27 is less, keep here. Then we have 38 and 82, 38 is less, 43 and 82, 43 is less, and 82. And this is our sorted array. Now always remember, don't get confused that at the time of sorting algorithm, definitely we will start with some unsorted array and list, and the end result will always be a sorted list or sorted array. Only the methodology, the algorithm is changing. That insertion sort is something else, in selection sort we are doing something else, and in merge sort we are doing something else. In bubble sort we have done that swiping part. So it is eventually that the techniques are going to change, the time taken in doing this process, but ultimately the resultant of all the sorting algorithm will be same, which is a sorted array. Let us move ahead to the last topic of today's video lecture, that is quick sort. Like merge sort, quick sort is a divide and conquer algorithm. So what we have seen that merge sort and quick sort are based on divide and conquer. So this question can be asked, what are the example of divide and conquer technique sorting algorithm? So you can directly say that it is merge sort and quick sort. They use this principle. Now the idea is it picks an elements as pivot and partitions the given array around the picked pivot. So you can say pivot is a key element which will be utilized in doing this sorting. There are many different versions of quick sort that pick pivot in different ways. So there could be many rules of picking up the pivot. The first element can be picked, the last element can be picked. In my example set I have implemented the last element one. A random element can be picked as a pivot, and the median position will be picked as the pivot element. Now the point is what this pivot is going to do. this pivot is going to decide that what will be the elements which will be kept in the left hand side or at the right hand side in the array. So let us see with the example itself. This is the unsorted array here in this portion, and as I said, we have implemented in this example set the last one element is chosen as a pivot element. So we have used this 3 as a pivot element. Now the idea is that we will be dividing. This is quick sort again, based on divide and conquer. We will be dividing the array definitely, but division will be on the basis of this pivot element. So this pivot element will be the center. The lesser values, lesser and equal to values will be kept here in the left hand side. The greater and equal to values will be kept over here. Okay, less than and greater than. So out of this -3 is less than 3, 2 is less than 3, and 1 is less than 3, which will be kept here. And this -6 also, I forgot. And then this 9, which I am putting here, 9, this 5, this 6, 8. These are all elements which are having greater than value, so they will be kept over here in the right hand side somewhere. Okay, earlier in case of merge sort, we were only simply dividing without any rule. Here we are dividing with the rule of that 3 will be kept in middle, less than values will be in the left hand sub-array and the right side sub-array. Again, because the policy is choose the last element as pivot. Last. Okay, so here the last element is this 1. In this case, the last element is 6. So we will be choosing them as a pivot. So 1 is chosen here as a pivot and 6 is chosen here as a pivot. So the less than values like -3 and -6 will be kept over here, and 2 is greater than will be kept on the right side. Likewise here in this example, less than value, which is 5, is kept on the left hand side, and 8 and 9 are greater than 6, so they will be kept at the right hand side. And the last -3 and 6, they will be done like this. Okay, so now if I start sorting, if I start using the array at most sorted out, if we merge these two elements, see -6, -3, 1, 2, then we have this 3. You need to follow the tree, right? This we'll be having a sequence 6, -3, then we'll be going to 1, then 2, then 3. Okay, then we'll be covering 5, 6, and then we have 8 and then 9. So ultimately in the last step you can see the array is sorted, right? The idea or the point of choosing the last element as a pivot is not a confirmed or sure thing. You can use this first element also as a pivot, but in that case, when you have the subdivision of the array, when you have a division of array at one step, every time you know, because we have used here the last element, so every time if you have used first element as a pivot element, every time you will be using the first element as a pivot for division. Whatever policy you do, you need to keep it constant till you get the sorted array. That's all in quick sort. So we'll have a summary. The summary is a little bit telling about the facts that insertion sort is used when number of elements is small. Why I'm saying so? Because insertion sort is in which we pick certain element and try to insert at a particular place, and once you insert, the other elements are needed to be shift in case of array for insertion. It can also be useful when input array is almost sorted or only few elements are misplaced to complete the big array. Quicksort is an in-place sorting algorithm, which means it does not require any extra or temporary list to perform sorting. Everything will be done on the original list itself. So remember, it was discussed that quicksort is a very good sorting algorithm and it is in place, right? So we do not require any extra place. We can swipe the things inside. Quicksort, when implemented well, it is the one of the best sorting algorithm. So I just want you to note down that this is one of the best sorting algorithm. And when we talk about the sort function provided in most of the language libraries, they are implemented using the quicksort itself. So quicksort is one of the best technique, as you can say, in general programming environment. That's all. These are some of the references, and this is my contact information. If you have any query regarding the video and regarding the subject, you can always contact me. I will be happy to answer. Thank you for watching and keep learning.